Hello and welcome to the course on C Programming Learn to Code series. This is the first lecture of Unit 2 and in this lecture we will introduce the concept of programming language. So we are going to discuss three programming languages quickly, that is your low level language, middle level language and high level language. So let's begin with the discussion. So first of all, I would like to ask a question, that is how to instruct a computer. So how do we give instruction? We need to learn a programming language to give any instruction to the computer, because a program is nothing but it is a collection of instructions, right? So which programming language we should learn? We need to learn any of this programming language of our choice. So that will be divided into three times, that is your low level languages, middle level language and high level language. Low level language is sometimes called machine level language because this type of language does not require to be converted into machine form, because machine can directly understand this type of language. Middle level language, that is sometimes called assembly level language. So assembly level language needs some translation program, so that language need to be converted into machine form or machine language form so that the computer can directly understand it. And the third is, that is your high level language. So today's all the programmer generally reads about any of these high level language. There are several other high level languages are also possible. I have mentioned some of the popular programming high level programming languages. Those are C, C++, Java and Python. So let us first understand what do you mean by low level language or the machine level language. So generally this is a particular language which can only understood by the computer directly without any translation program. So that I have written in the first line. So this is basically written in the form of 1 and zeros. So that's why as the computer is an electronic device and it can only understand ones and zeros, so we don't need any translation program. So that means we have to write the code in the form of 1 and 0 and the computer can directly understand that is that particular program. Okay, but it takes the following form. So whenever any instruction is written in case of a machine level language, the form is there will be opcode and there will be an operand. So what is an opcode? Opcode specifies any operation code. So there are several operations can be performed inside a computer. Let's say add is an operation, multiply is an operation, subtraction is an operation, division is an operation. So you have to specify the opcode over here. Every opcode, so these are the operations, there will be some code associated with it. Let's say 1110 may be the code of your addition operation, multiplication operation may be 1101, subtraction operation may be 1011, maybe, means I'm just mentioning some line. So which indicates that the low level language is obviously written in this form. So you have to specify the opcode here. Let's say 1101. So it specifies a multiplication symbol. Then you have to specify the operands. So what does mean the operand is? The operand means upon which the operation is going to be performed. For an example, 5 plus 7, if you want to perform this operation, then here 5 and 7 are operands and plus is called the operators. Okay, so you have to specify the operator over here. That means what type of operation you want to perform. Then you have to specify the location of these operands, that is 5 and 7. You know that every computer has a memory and every memory location has some address. Let's say this is 0001 1011. So these are the addresses of that locations, and somewhere these operands are getting present. So 5, let's say 7 over here. Then your complete instruction could be something like this: 1101 for multiplication. So sorry, this is addition. So for addition we have to use 3 ones, 111 1110. Then you have to specify the operations locations, that is 00. Then you have to specify the second. Maybe the instruction maybe look like this. So you have to write the code something in this manner. Okay, so as I have already told you, opcode and operand. Opcode tells the computer which operation to perform from the instruction set of the computer. Operand tells the address of the data on which the operation is to be performed. Okay, so it is looking very tricky, and obviously it is tricky, and you have to remember all the codes for every operation you want to perform inside the computer. So it is something written like this. Okay, a program, maybe this is a program, this constitutes a program which contains 5 lines, and these are the codes it is written over there. So to remember this properly, generally what happened, the person who is writing the code, he generally converts the numbers or the binary numbers into decimal, so that it can easier to remember, because there are less symbols as compared to the binary number. Sometimes they may also convert this syntax into hexadecimal, which is contains very less symbols, so that we can remember it properly. So obviously there are some advantages of using this low level language. So what is the advantage? It will be execute faster. So why faster? Because as the computer does not need any translation program, means it does not require any translation, he directly understands the language or directly understands the statements, so he will execute it faster. Okay, and but there are several disadvantages. So what are the disadvantages? So one is your machine dependent, because every machine has different code of executions, so you need to learn their code. That means every operation is, one machine may use 1110 for multiplication, but other machine may use 1100 for multiplication. So you have to remember all these codes properly. So that is machine dependent. So difficult to program, obviously it is difficult to program. By seeing this code you can understand it properly. Error prone, somehow suppose you have written a program and somewhere 0 becomes 1. So how do you find that where the error is? It is so difficult, even if you are finding it, but it's difficult to find the error present inside your program, and it is difficult to modify too. Okay, so these are the basic disadvantage, or that is the main disadvantage of low level language. That's why the computer programmer realized that we should use some mnemonic to remember the codes. So mnemonic means it is a short form we are going to use. Instead of using the 1010, we have to give a name to him, and we will use remember that name. Let's say 1110 is used for the addition code. You can remember it by the help of add. So how the assembly language look like? So it will be looking like this. So I have given here an example, that is LDA A7. So this is the instruction, this represents the opcode. Okay, so what type of operation you want to perform, and these are the operands upon which the operation will be performed. Okay, so what does it mean? The entire meaning of this is load a register with value 7. So what is a register? Inside your CPU, generally I have already discussed this in the fundamental concept. So inside the CPU there are several registers present, where the contents are transferred from the main memory. So main memory contains the operands. Okay, so those operands are generally transferred to the registers, and the operation will be performed inside the CPU. So CPU performs the operation on these registers. Okay, so the meaning of LDA A7 means load the register A. So there is a register known as A, generally it is called accumulator, with the value 7. So you have to load the 7 value to the register A. Okay, similarly LDA B10, that what does it mean? It means load register B. Let's say there is another register B which is loaded with 10. Okay, then it is written add AB. Add AB means add the content of AB and store it in C. That is A is equal to A plus B. This symbol is represented in the algorithm I have already discussed. This symbol is used for assigning the value that will be present in the right side to the left side. So we have to add the value of AB, that is 7 plus 10, which is nothing but 17, and we have to store it in A. So the answer is 17, which is stored in A. Then you have to stop processing. So this is how a assembly language programming is written. But if you directly send this program to the computer don't understand it. So what do you need? You need to convert this instruction. Every instruction need to be converted into 1010 format. Okay, then only the computer can understand it. That's why a computer needs a translation program. So a translator is needed. In case of assembly level language, a translator is needed to understand it, and that translator is in case of assembly level language is called as assembler. Okay, so what is an assembler? A assembler is a software. So assembler is generally written in some language, and it is a software that translates an assembly level language program into an equivalent machine language program of a computer. Okay, so the things are something like this. So you have a assembly language source code. I have already shown you how the source code look like. That is your add A plus AB, LDA, A7. So those are the source code. So that source code is need to be inputted to the assembler. What is an assembler? Assembler is a software. So this software will convert each line of that code into the corresponding machine level codes. Okay, sometimes it is referred to as object code. So those code can directly be understood by your computer, and it is native to that architecture. Okay, so that means the computer can only understand that code only. Okay, so the assembler will convert the assembly level language into machine level language. Fine. So there are several advantages as well as disadvantages. So what is the advantage? As I have already told you, means the disadvantage of machine level language, you just compare it with it. Easy to use and easier to understand as compared to the machine level language. Obviously, we have already discussed this. Easy to locate the errors and correct it, because we are writing it with some mnemonic code. We can understand the language properly and we can find the error easily. Assembly language has the same efficiency of execution as the machine level language, because this is a one-to-one translator between assembly language program and its corresponding machine level program. So generally it is called the efficient one as compared to high level, because every line of code in the assembly level language is correspond to a particular symbol in the machine level code. Like if you are in machine level code, let's say you are using 78 for adding two number, then the assembly level language you have written add a b, then you can just change this line to 78. The assembler will change it to 78, and whenever I type 78 in the keyboard, then it performs the addition operation. Okay, so this is a one-to-one mapping. So that's why it is easier to understand, because whenever you are going to input this value, or input means execute this value, you need to specify that number by typing on the keyboard, so which is very much quite easier, and that is why this is have the highest capability or efficiency. Okay, so what are the disadvantages? But still the disadvantage will be exist. One of the significant drawback is that assembly language is a machine dependent. Obviously, because I have already told you every machine has different code, and you are only using a mnemonic for that. You are not changing the code here. So you are using a mnemonic, and that mnemonic will be helping you to write the code, but never you cannot change this code at all. Okay. So a program written for one computer might not run in other machine with different hardware configuration. That means if you are writing an assembler for a particular machine, that will convert add AB to 78. For other machine, the add may be 59. So that's why you need to write the assembler for that in a different manner. Okay, so that is the main disadvantage. A conversion program is needed to convert assembly language. That is not a disadvantage, but we can include it inside that, because every assembly language program needs a converter program, or that is called the assembler. Fine. So the last one is your high level language, which is nothing but it is a machine independent language. It does not require the dependency of the machine, because compilers are there. Every compiler is different from machine to machine for a particular program. So a high level language is simple English like language. So it is very much easier for the user to understand, because user knows how to write English. So for them it was a very good form of language. So there are several high level languages are there, like C, C++, Java. I have already discussed in the first slide itself. So it is easy to manipulate, easy to read, easy to understand. So that's why high level languages are generally used in our means every programmer is trying to read a high level language. Similarly, as like an assembly level language, you need a assembler. Here you are also going to use a translator program. So there are, for high level languages, there are two types of translator program generally written. Translator program is nothing but this is a software itself. So two type of software is written. So one is called the compiler and another one is called the interpreter. Okay, so quickly saying the difference, the compiler is generally parse or read all entire program at once and find out the errors, but an interpreter will execute each line of the program and say the error in that particular line. Okay, so it will be executed, means it will process it line by line, while compiler will execute it or checked it and check the entire program at once. Okay, so what is the role of a compiler? A compiler is a program that translates the high level language program into a machine level language program. So the figure is something like this. You have written any programming language. Let's say you are using C programming language and you have written a code, and that code need to be inputted to the compiler. The compiler will convert the high level language into corresponding machine level language, and that machine level language will be directly executed by the computer itself. Okay, so the figures are similar as like the assembler. Here only I have changed the assembler term into compiler term. So I hope you understand properly. Finally, we need to understand that every language that we are going to use in the high level case, where whatever high level language you are using, every language has a separate compiler. Like if you are using C program, then you got a separate compiler, that is C compiler. For Python program, you need a separate compiler, that is your Python compiler, which will convert the Python code into your machine level code. And as I know, the Python programs are nothing but that is a interpreted language, so there may be interpreter present over here who will convert the lines of code into your corresponding machine level code. Okay, so every language have a different compiler installed in it. So that's all for the today's class. I hope you understand, but there will be a task for you. You can search it yourself, what is the difference between compiler and interpreter. You can search it and you will understand many things whenever you are going to search for this. So that's all for the class. Thanks for listening. Bye bye.